to do with your soil? What do you want to do? Oh, through the strainer.
Yeah, through the strainer, and then we're gonna do the plop test on all of them.
Nice.
So I need more hands.
So what are we doing?
So the clod, basically, we're looking to saturate. Go ahead and pop them in.
Oh yeah.
Yep. So
Push it
then.
through the strainer.
Yep. Just letting it get completely saturated. Now they're already kind of saturated, and also, yeah, we've got larger clods here. So the slump test, you know, we're looking at aggregate stability. What the heck does that mean? So all of that mineral soil without the biology, and now the biology, fungal, microbial, plant sugars, glomalin, all those interesting concepts we can't see to the eye are exuding things. Sugars, microbial populations have this alkaline slime. Fungi is exuding hydrogen and probably other things that I can't remember off the top of my head. And they're building structure, hence why we walk into a forest and it feels fluffy, right? Fungally dominated soil. The fungal relationships are building a lot of that, as well as the carbon input.
You got your minute.
Okay.
There was some extra water from
Pretty well set.
help flipping them over.
Yep, so we're
Oh,
going
I
to try
see.
to
Oh,
keep
on the
it
plate?
straight.
You
Yep.
want to pick those up and put it. Oh yeah, you know which ones are which.
We'll just
Doesn't
we'll
matter?
just put them on over. Keep the cup with it though.
Okay. Do you want to keep this upside down to catch some, or you don't care?
We don't care. We're gonna make a
Some of
mess.
these rings.
We're definitely gonna make a mess. Yep. Who are you?
That.
Forest. Oh, goodness. Let's see if we can find. There's Forest. Forest.
Oh, do you need? What's this one? Oh yeah, this is
So we
Annie.
not
want
all
to
marked.
we want to
There's
flip
Annie.
them all at the same time, right?
Oh, okay.
Or does it not matter? I'm gonna do it.
Relatively safe.
Oh, you didn't have
This is pasture.
Okay. You're sad.
And here's sod. Does it matter?
I like his method right there.
Well, I'm gonna do
Oh.
it that way. I don't know.
Yeah.
I'm not the expert. You guys. That's how I.
Well, you
was
can
gonna
flip
do
it, and like part of the abrupt change is part of the aggregation. So
So-
be as sloppy with it as you want.
Okay.
Okay.
Will you tell it?
Yep.
1, 2, 3.
Oh yeah.
We're gonna take the top off then.
Yeah.
That's the reveal.
Yeah.
Oh.
So, okay.
Big reveal.
Oh, I need
Do
one
I need
too?
to water?
Yeah.
Is that what I need to do?
Oh yeah, please. Thank you.
Yeah, and
Okay.
you can lift the strainer by itself so the water doesn't all come off. Or do you want
So-
the water? Or
I
do
know, you
want
tell
All right.
me.
This
What
one's
do
the
you
one I
want?
can't tell. So hedgerow. Okay. So we have
This is
forest.
Sod. I got sod.
Excellent. Thank you.
One just flipped over.
All right. So. Okay, so everybody can see that's our forest mud pie.
This is sod.
Sod. So that one's that plot right there. Has been tilled, you know, relatively recently. This one is pasture. Animal interface, right? This land's not getting manure, okay? Hedgerow. Hedgerow is basically right over there, same soil type, but just being clipped once in a while and not really being managed. So the least managed soils, the annual till, thank you.
Not
And-
holding up.
So we're talking about that biology building. Lindsay and Katie were talking about building that structure, right? So we have these monumental storms, and we want that structure to hold integrity through the soil profile. And one of the reasons why you get kind of that, apart from the mechanical impact, but the crusting, is that soil structure is not holding up with the mechanical impact as well as the rainfall impact, and it is filling itself in like concrete. Okay, our lawns do it. You know, there's all kinds of different things that are covered with vegetation that actually do it because there's too much impact to the soil, and it depends on the soil type too. Some are more forgiving than others. Anybody got clay?
Does the water sort of filter all the small pieces into the structure and make
Yes.
it more compact? Is that what's happening?
So here we have a lot of carbon input, we have a lot of fungal. And so in your forested soils, if we took an infiltration test, right, making some broad assumptions here, but if all of these were the same exact like soil texture type, and they all reacted differently. One of the main factors is the fungal development in here. It has just as much bacteria, different microbial populations, different successional stages of plant communities, but it's got a different ratio, a higher ratio of your fungal growth. One from the carbon input, two just correlations with trees, and then it hasn't had that disturbance mechanism, right? But our annual plants, like they can deal with the disturbance mechanism, and they love the microbial different populations. Here, cracking this guy open, we still have some airspace. We still have places, interstitial places where air can be exchanged, water can infiltrate, and biology can move. And wherever these roots go, that's where your biology is flowing to. Katie was talking about that earlier. Those plants are giving up the sugars. And that's another thing. If your plant is anaerobic and it's not used to being anaerobic, you're going to see reduction in growth. Same thing with temperature growth. If your soil is baking, your biology moves out of the area. Just like you wouldn't want to sit in the hot sun, neither do they. And so that whole system that we have approximately 6 months, maybe give or take, to be creating our soil aggregation is reduced that much more.
Yeah, and what you're talking about, or what I think you also were asking about earlier with like water washing the particles into those other spaces, when you don't have that like strong, well-developed soil structures, that's absolutely something that can happen. So you would start with the soil before that structure is built. It's called structureless, and it's just like a lot of particles of different sizes. And then without the building of those structures, what can happen as water is washing down, making especially like those small clay particles, they're tiny, they get basically suspended in the water, and it can wash them into the spaces and cause them all to glue together into like all of the spaces are being filled instead of having strong aggregates that keep some of those spaces
water,
protected.
instead of percolating down into the soil, it runs across the top and out into the...
Yeah, and it can glue your soil together, and then you're also going to get a lot of runoff because now there's small particles filling those spaces instead of room for the water to go in there. And that's definitely something that can happen, particularly in finer textured soils. So a lot of clays that can kind of fill into those spaces.
And I'm guessing that after something like what we've just experienced, what we're experiencing this summer, it's going to take a lot longer for those soils to recover than it will for the soils on the pasture or the forest.
I would definitely expect so, because you don't have all of those air spaces for evaporation to happen and for things to kind of like dry out and get back to being oxygenated. And we're going to have longer periods where water can't get out and it's being held there. Soils are anaerobic, doing all sorts of chemical cycling that they might not normally do, and it's going to be real interesting.
We've also got biological die-off.
Yeah, because a lot of organisms can't handle
plant
that.
roots and the microbes themselves, so you've changed the whole succession of biology within that soil, and it's going to want to go toward, you know, you're hoping that you're going to have enough of the fungi in particular that are going to be decomposers that are then going to be rebuilding the food sources again for the bacteria anyway. So.
Well, no, I'm glad you brought that up. 'Cause that's something that we're talking about microbes. We talked a little bit about fungus, but like mycorrhizae, right? So something like 90% of plants form that relationship, and mycorrhizae really helps plants access nutrients that they couldn't otherwise get to. So if you have like high colonization of mycorrhizae, you get something like potentially 90% of your phosphorus needs met and 50% of your nitrogen. And it also takes longer to grow back than the microbes do, so it can take longer for a flooded soil to recover because of the microbes and because of the mycorrhizae. And I think I just want to say this one other thing before you go on, Carissa. I feel like so much of what we're talking about here was about pore space, right? Especially when we're talking about flooded soils and aeration. And I think so. And so what we want is like our soils to have like 50% pore space, and that can be filled with either water or air, depending on what's going on in our environment. And so much of that is influenced by management, inherent soil properties that we were talking about earlier, and that influences the habitat of the microbes as well, and is also very, very influenced by the amount of organic matter creating in that space.
Yeah, you touched on an interesting topic on your, like, you mentioned about the soil bacon, and then therefore your microbial diversity would have to be decreased in the process because you're losing some of them that don't handle the higher temperatures when that happens. Now, that's kind of cool because with the winter rye being planted, that's creating shade to help keep the soil cooler, so you're going to have a higher microdiversity, won't you?
Yeah, so it absolutely, like, creating conditions conducive to the plant life, and in specifically talking, so there's a broad mix of aspects on this farm, like warm season, or annual versus perennial. They all have their little niches, so a plant community is not a plant community is not a plant community. But then, like, trying to push those systems, whether microbially, if they're microbially dominated, and now annuals, like my spectrum there, and then you're going to your perennial forages, they're kind of like the 50-50 I like to think of, although I'm broadly speaking. They want, they need the carbon input, they need the microbial input, they need both of them in order to sustain themselves. And then you have the forested aspect where they need that carbon input, and we've heard about the jumping worms and everything else, and that's where that, like, oh no, the nutrient cycling is shifting in those communities, and that's one of the big things with that. I'm not sure if I answered your question. I'm sorry.
Well,
My brain went to that spectrum.
Thinking that the winter rye helps keep the ground cooler, so therefore you're not baking some of your microbes that would then die off because it's too warm for them.
Yes, and you're also like, okay, think about the time frame that we're planting corn, and one of the big key things to think about is where the root goes, the energy or the biology is going to, right? We don't want to dig a soil pit to get to, to get our the biological community in there. We're hoping, and we're typically topically spraying things or putting things on or applying that are going to feed our soil. But it's not just rain that takes that through the soil profile, as we were talking about the dung beetles. They are like snatching that and taking it down.
I thought that was really cool.
Yeah, it really is, and they're part of that whole system of creating those channels for airspace. But historically speaking, if we depart from our mechanical world and all these great tools that we have, this is how nature did it. It did it through the roots, and the roots are exuding those sugars that are calling in those microbes, and those microbes are coming to the dinner table, and then something else is coming to the dinner table to say, oh, microbes, and they're eating them biologically, moving them through their system and feeding that plant. And it behooves the plant to have that, all those different aspects. Mycorrhizal fungi just to be fungi, microbial populations, like those relationships, because that plant can't grow legs and go get that pizza that it's craving, so to speak. It's just like, it's like one of those advantageous things for our plants to be able to have an army at its will that says, I want that sugar, what do you need,